Now, for question 5, it is talking about an experiment was carried out at 298 Kelvin to study the acid catalyzed hydrolysis of sucrose. The sucrose can be hydrolyzed to become glucose and fructose. Now, although we don't know about such reaction or learned before, we can still continue our doing or working on this one. The table below lists the concentration of sucrose at different times interval. So we have 0, 60, 120, 180, and 240. Now, please make sure that this time, the time per minute that is given is in one set of experiments. So this one set of experiments, that is, we have glucose placing here, and then we just wait for 60 minutes 60 minutes, and then try to find out what is the concentration of sucrose, and then wait another one. So it is the 120 minutes, how many concentration there. Why I need to study about this one first? Just because some of the time, or some of us will use 1 over time equals to rate to put about this one, then it will be wrong here. Now, for 1 over time equals rate, that is for different sets. For example, we have experiment 1, and then we find that the finishing time is about, say, 50 seconds, while the concentration is A. While experiment 2, we have the time is 100 seconds or 100 minutes, while the concentration is 1 over A. And then we have experiment 3, so on and so forth. Like if we have different sets of experiment, and then with different time given, then we need to 1 over time it to give the rate, because this one is the ending time that we have got. That is 50 seconds, for example, then the reactions end, 100 seconds, the reaction end. So this is for different sets of experiment. However, for this one, we just got one set of experiments, which is placing the sucrose into the flask and then wait 60 minutes. So determine about the concentration, 120 minutes, determine about the concentration. So with such understanding, we continue by plotting a suitable graph, show that the hydrolysis is first order with respect to sucrose. That is, the rate of equations can be represented this one. So we would like to confirm whether it is the first order of reaction with respect to sucrose. Now, if you refer to the given answer that is here, it is used the logarithm and then time. Now, this is actually another half-life equation, but we didn't learn that in our DSE chemistry level, so we skip the lateral log one. So what we can do is here, when we get the concentration and then got the time, so you just need to directly to plot the concentration time graph. Now for such concentration time graph, as it is the first order, you should be able to get a curved here. So it should be a curved line here. Well, for such a curved line, how can we know that it is a first order reaction? Now, as far as we have learned, the first order reaction should have a constant half-life. That is, originally it is 100 now, and then the final one at 240 minutes, it is 44.1. Then we want to find about the half-life, whether it is a constant one. For example, here we can find that for the 120 minutes, it's decomposed or it's reduced 44 units of the concentration, that is going to 66. While another 120 minutes, that is here 240 minutes, at the 240 minutes this time, the one that we have is another, this is 22. Now this one you can see it is already getting half of the original. As a result, we say that we have a constant half-life here. That is, when it decrease 44, it need 120. If it's decreased further 22, that is half to the previous one, we need another 240. That is, it is having a constant half-life now. As a result of that, we can confirm that this is a kind of first order reaction. So remember, if we want to use a graphical method to find out the reactions, whether it is fit for the first order reaction with respect to the concentration of reactants, so we can plot the concentration reactant time graph and then find out whether the half-life, the constant half-life presence or not. This is question 2. While for question 3, using your graph in 2, determine the K pi at 298 Kelvin. Now, I know that if you use this one, it will be a little bit difficult for us to do. However, we can still find this one. For example, if you use this graph, so when we use the graph plotted here, we can get the instantaneous rate. For example, we can get an instantaneous rate at 120 minutes. So you can find a tangent line here. The slope showing here, this slope will be equal to the rate of reaction. Now, if we have the rate of reaction, and then at 120 minutes, we got the 66.3 here. We have the rate, we have the concentration, we can determine the K pi then. As a result, all you need to do is to find out how can we get the rate of reaction. The rate of reaction can be found in the graph from the slope of tangent line. So we can get this one. The slope equals to the rate, while the slope equals to the rate, and then we need to know, at 120 minutes, what is the concentration then? Rate of reaction known, concentration known, then we can calculate about the K pi. Now the value of K pi, it should be, I would rather use back the one that we have here in the answer. So for this one, it should be equals to 5.7 times 10 to the negative 5. So this one would be the answer. Or some of you will use back the minute as the unit. So you just need to change it back from the per second to minutes. Then it's also an acceptable answer. Question 4. Suggest how you would show experimentally that the rate of hydrolysis is also first order with respect to hydrochloric acid. Now, if we want to show the order of hydrochloric acid, we need to keep the concentration that's used for the sucrose constant. That means constant concentration. Now, different experiments, we have to do different experiments first. Different experiments have been performed with constant, with the sucrose unchanged concentration here. If the concentration of sucrose unchanged, while we change the hydrochloric acid concentration, we give, for example, 3 to 4 sets. One is, take an example, 0.1 m, 0.2 m, 0.3 m, so on and so forth. So we get few sets of hydrochloric acids concentrations, and then with the concentration of sucrose, didn't change it. And then we study, we have to confirm with the rate. And then we need to study about the rate of reaction, whether it's changed or not. However, as we are talking about the first order reaction, we want to show experimentally that it is the first order reaction with respect to the hydrochloric acid. So we need to talk about the reaction rate will be double if the concentration of hydrochloric acid used doubles. So we have to use this method to show it, or the direction it is directly proportional. Doubled rate of reaction by using double hydrochloric acid, then it will be having a first order reaction. Now, please remember that as we need to confirm it is first order, you have to tell me about whether hydrochloric acid and the rate of reaction relationship. Once double for the hydrochloric acid's concentration, we have doubled rate of reaction. That's why you cannot just only say they are vary. When hydrochloric acid increase in its concentration, the rate of reaction increase. Like this is too general. This can be applied for the second order as well. So you have to specify, focus back what is needed is about the first order. So you have to stay back or double hydrochloric acid concentration, rate of reaction double. So that's why we have to be precise on that. That is the question 5 in the further exercise, chapter 51.